Did you know that 96 kind of looks like a cool person with sunglasses? See? Like, these are the glasses, the nose. Look at that. Perfect. Beautiful drawing. We got it. Let's do some problems and let's talk about scientific notation. Okay. So let's just jump right into the problems with question number 1. Look at the views, the likes and dislikes. I don't think these are visible on YouTube anymore. Or maybe they are. I don't know. There's been a big... I'm not going to talk about YouTube today. Let's do the problem. And the number of people that are subscribed down here. K stands for thousands. M stands for millions. Write the number of views in scientific notation. Well, there's this many views. 7.13 million. How do we write that in scientific notation? So remember, scientific notation is always in the same format. It's a number it's a 1-digit number, and then however many decimals we could want, times 10 to some power. This is an example of scientific notation. But remember that this is always only 1 digit. We can't have this 2 can't be a 10 or an 11 or a 15. Can't be a 0 either. So it has to be some digit right there. And then we can have as many decimal places as we want, and it'll end like this. So here, this is going to be 7.13. That's what we need. And the question is, when we multiply it by 10, sometimes we use an x for multiplication. You can also use this multiplication sign. What's the exponent? Well, if we just multiply it by 10 to the first power, that would move this decimal place once. 10 squared would move it twice. How many times do we have to move that decimal place? Well, we have to move it from, if it starts here, we'd have to move it 1, 2, 3, 4, 5, 6. 6 places. 7 million. Million's going to move it 6. So this is going to be our answer here. And we can always check our answer by going the opposite direction. Okay? Times 10 to the 6th means 6 zeros. 1, 2, 3, 4, 5, 6. Is this the same number that we started with? Yep. It is. So we can always check our answer. Got the same thing. Let's type it in and see what MyOpenMath thinks. 7.13 times 10 raised to the 6. Ooh, I thought they were going to get mad at me for using the dot instead of the X sign. Okay. We can go on like this as well. Let's do maybe one more. The subscribers. 1.5 million. Now let's do the likes. The likes is 150K. Well, there's 150K likes. What is 150K? K is thousands. That's 150,000. Let's just do the same thing. We know it has to look like 1.5 because of the format for scientific notation. The first digit, it's a 1. And then everything after goes after the decimal place. So here we had 2 things after the decimal place. Here we only need 1 because everything else is 0 after that. 1.5 times 10 to what power? We'll do the same idea. If this is the decimal place, 1.5, how many places do we need it to move? 1, 2, 3, 4, 5. So that's our answer. We could check it using the exact same process, but I'm not going to. 1.5 times 10 to the 5th. Let's see if we got these answers right. Neat. We did. Move on to number 3. What about negative exponents? Remember, if it's 10 to a negative exponent, that's like dividing by 10 a bunch of times. It's moving the decimal place the other way. So on question number 3, 6.85, times 10 to the negative 2. This is just 100. We just move, that's 2 zeros. 2 zeros. Since it's negative, we move the decimal place the opposite way. 1, 2. Now we're going to get 0.0685. And that's a fine answer, but I really like writing the leading zero here. 0.065 is good. Okay. That should be our answer, 0.0685. I think it'll take both answers. Oh. I can write my digits in the right order. And it should take it even without the 0. Yeah, it does. Great. But the 0 is nice. And the reason the 0 is nice is it just makes it obvious that there's a decimal place here. This is kind of small. I don't know how good your eyesight is, but if you put the 0 in front, then it makes it more obvious. All right. Number 4. Let's go backwards. Let's now write a very small number in scientific notation. We got 4 zeros after the leading 0. Leading 0, 1, 2, 3, 4 more. 7, 4, 1, 5. Big numbers are going to have positive exponents. Small numbers mean that in scientific notation, we're going to have negative exponents. So we approach this the same way. What's that form for scientific notation? 1 digit, then a decimal, and then all the rest. So here, what's our first digit? Our first thing that's not a 0. 7. Decimal place, all the rest. Now it's always times 10 to some exponent. And because we started with a small number, a small decimal, we know our exponent's going to have to be negative. Question is, how many times do we have to move the decimal place? Well, we have to move it to the left. That's why it's negative. 1, 2, 3, 4, 5 times. So this should be our answer, and we are going to check it. This number is what happens when you take this and you move the decimal to the left 5 times. 1, 2, 3, 4, 5. This is our new decimal place. There are 4 zeros after the decimal place. Great. 4 zeros after the decimal place is exactly what we wanted. So we checked our answer, and it checked out. 7.415 times 10 to the negative 5th. Got it. Let's do 2 more, the messier ones. This next one's really great because there's a really easy mistake to make. And I want you to think as I'm working through this problem, what did he do? All right, and then I'll talk about it before typing in my final answer. So when you multiply or divide numbers in scientific notation, remember what I said in the 95 video this week, if you watched it, is that multiplication can be done in any order. So over here, when we have 9.6 times 10 to the second times 7.4 times 10 to the 9th, really, we can write this multiplication in any order because there's no addition. We don't have to worry about distributing or anything. So this is really just 9.6 times 10 squared times 7.4 times 10 to the 9th. Oh, we can do this in any order, so let's do it in a nice order. 9.6 times 7.4, can do that by hand or with a calculator. Times 10 squared times 10 to the 9th. Definitely can do that one because we just had a wonderful same unit information on exponents. We know how these exponents work. What a coincidence. Scientific notation uses exponents, and we just talked about an exponent. Wow, what are the chances? It's almost like somebody designed it that way. All right. I'm not going to do this one by hand. I'm going to pull out my handy dandy GeoGebra scientific calculator to find 9.6 times 7.4. 71.04. All right. And then we multiply these guys. It's just adding the exponents. So why is this not the correct final answer? Let's go back to how we started. Oops, that was 95 stuff. We got the cool 96 sunglasses. This is what our answer should look like. 1 digit. And then a decimal. And then everything else. Uh-oh. We don't have it in that right way. We need to move the decimal place 1 over. So if we do that, 7.104, what happens to the exponent? Does it get smaller or bigger by 1? So remember, bigger numbers, positive exponents. 71, not huge, but it's a bigger number. So it's going to be adding an exponent. If you have smaller numbers with decimals, that's going to be negative exponents. So this is a bigger number right here. Going to increase our exponent by 1. And you can always check. Always check. So if we wanted to, this guy over here, 7104, and that decimal gets moved 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you can do the same thing, count the number of zeros. Let's do it. Why not? 7104. We're moving the decimal 12 times. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. Hopefully they have the same number of zeros. Wait, I feel like I messed up. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Great. I got really worried there for a second. So they're the same number. You can't always do this. If you have like 50 zeros, you're probably not going to write out all 50, but for a lot of problems, you can check it this way. All right, so yeah, make sure that your final answer is in scientific notation. 7.104 times 10 to the 12th power. How'd we do? Easy. We do the same thing for number 13. Same thing for division. Let's multiply all the numbers, the number parts. I guess they're all a number part. Let's multiply all the first parts and divide all the first parts, and then deal with the scientific notation-y part. So on this one, I'm not going to copy down the problem. This is number 13. We're going to take 2.024, multiply it by 4.278. Your decimal's in the wrong spot, Jason. That's not going to be helpful. And we're going to divide it all by 3.174. And we're going to do the same thing with the scientific notation-y part. I'm a very professional math professor here, okay? That's going to be times 10 to the 12th times 10 to the 35th divided by 10 to the 37th. So we do that with our handy dandy scientific calculator. 2.024 times 4.278 divided by 3.174. Remember, this looks a little different, but because of how multiplication rules work, my answer will actually be the same as if we typed it in with parentheses. 2.728 times 10. Add the exponents on the top to get 47. Subtract 37, you get 10. And we make sure is our answer in scientific notation, or do we need to do another step? It is in scientific notation. 1 digit, decimal, then all the rest of the digits. Or it should be done. Unless I made a silly mistake. 2.728 times 10 to the 10th. There it is. Let me know if you have questions about any of this. I like talking about scientific notation. There's some cool applications. Mantissa. That's a new word for me. That's interesting. Huh. I guess it means this. All right, let's do some. Yeah. How have I not noticed that word in this homework assignment until today? All right, well, there you go. Extra bonus vocab word. Nice. Bye-bye.